Have you ever encountered a quadratic equation that seems impossible to factorize? Completing the square method makes you feel frustrated and you scratch your head thinking, how in the world would I solve it? Well, all your frustration ends with one name, the quadratic formula. So today we will learn how to use quadratic formula to find solution of any quadratic equation, whether simple or complex. So let's get started. You all know that the standard form of a quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0. If we apply the method of completing the square, we get the following values of x. X is equal to minus b plus minus under root b square minus 4ac upon 2a. This is known as the quadratic formula. Consider this expression square root of b square minus 4ac. If b square minus 4ac is less than 0, it means it is a negative number. So what can be the square root of this number? Is there any real number whose square is negative? You must have heard many times that square is always positive. This means the square root will not be a real number. So we can conclude that the real roots will exist only when b square minus 4ac is greater than or equal to 0. And we can see that this expression has a significant role in the roots of an equation. So this expression b square minus 4ac is known as discriminant of the equation and is denoted by capital D. So I suggest that if you are asked to find real roots, then before applying any method, you should first find the discriminant. If d is less than 0, you can simply write that the real roots do not exist. And this also saves our time because we don't have to solve the equation further. Now let us discuss some examples to understand how this is done. The first equation is 2x square minus 7x plus 3 equal to 0. Remember that before you solve the equation, it should be in standard form, that is decreasing powers of the variable. Otherwise, you will have to rearrange the terms. This one is already in standard form. If we compare this equation with the standard form ax square plus bx plus c equal to 0, what are the values of a, b and c? We can get them by comparing the coefficients of same terms. So you can see that we have 2 with x square, which implies that a is equal to 2. Similarly, b is equal to minus 7 and c is equal to 3. Now let's find out the discriminant d equal to b square minus 4ac. Replacing the values, minus 7 whole square minus 4 into 2 into 3. Let's solve it further. Minus 7 square is 49, 4 2s are 8 and 8 3s are 24. So we have 49 minus 24, which is equal to 25. It's clearly greater than 0. It means the equation has real roots. So let's find them out. We are going to use the quadratic formula. So the roots are given by x equal to minus b plus minus under root b square minus 4ac upon 2a. Replace all the values here. The value of b is minus 7, so minus b will be minus into minus, that is plus 7. This part is the discriminant and we have already found it, so we can directly use it here. And the value of a is 2. Solving further, we get 7 plus minus 5 upon 4. Now we will separate the two values. So we have x equal to 7 plus 5 upon 4 or x equal to 7 minus 5 upon 4, which gives us x equal to 3 and x equal to 1 by 2. These are the roots of this given equation. So unlike the other two methods, we directly put the values and simplify it to get the roots in this method. Next we are given 4x square plus 4 root 3x plus 3 equal to 0. It is already in standard form. So comparing, we see that a is 4, b is 4 root 3 and c is 3. So quickly find out the discriminant. We have 4 root 3 whole square minus 4 into 3. Now square both these terms. So 4 square is 16 and root 3 square is 3. 16 3s are 48. Minus 4 4s are 16, 3s are 48. So finally we get 0. This means the roots are again real. So by quadratic formula we get x equal to minus b plus minus under root b square minus 4ac upon 2a. Replacing the value, we have minus 4 root 3 plus minus under root 0 upon 2 into 4. Square root of 0 is 0 itself, and you know that 0 has no contribution in addition or subtraction. So we can just write x equal to minus 4 root 3 upon 8. Cancelling this, we finally get minus root 3 upon 2. It means both the roots are minus root 3 upon 2. So did you observe that the equation has equal roots if the discriminant is 0? Now the next question, we can solve it directly also, but let's simplify it a little bit because it has a fraction which makes it little complicated. How can we remove the fraction? Like we have done in previous lessons, we can simplify this equation by multiplying throughout by the denominator, that is 2 here. So 2 into 1 by 2 becomes 1, and we have x square minus 2 into root 11 is 2 root 11x plus 2 into 1 means 2 equal to 0. This is again in standard form. So we get a equal to 1, b equal to minus 2 root 11 and c equal to 2. Therefore, discriminant is equal to b square minus 4ac, that is minus 2 root 11 whole square minus 4 into 1 into 2. Minus into minus is plus, 2 square is 4 into 11, that is 44, minus 8, which is equal to 36. This is also greater than 0. Therefore, the roots are real in this case also and are given by x equal to 2 root 11 plus minus root 36 upon 2 into 1, which is equal to 2 root 11 plus minus 6 upon 2. You can observe that 2 is a factor of each term in this expression. So we can simplify it further by taking common and cancelling this 2. Numerator becomes 2 inside bracket root 11 plus minus 3, and this 2 cancels with the denominator. So the two roots are x equal to root 11 plus 3 and root 11 minus 3. Next is root 3 x square plus 2 root 2 x minus 2 root 3 equal to 0. It may seem very difficult to solve, but it is not. Just be little more careful while using the values. And don't forget to check the standard form. So here we have a equal to root 3, b equal to 2 root 2 and c equal to minus 2 root 3. So discriminant will be 2 root 2 square minus 4 into root 3 into minus 2 root 3. Squaring this, we have 4 into 2, that is 8. Root 3 into root 3 is 3 and 3 4s are 12 into 2 is 24. So 8 plus 24 gives us 32, which is again greater than 0. So as per the quadratic formula, the real roots are given by x equal to minus b plus minus under root b square minus 4ac upon 2a. That is equal to minus 2 root 2 plus minus root 32 upon 2 into root 3. 32 can be expressed as 16 into 2. 16 being a perfect square comes out of the root and we get 4 root 2. As the factor 2 is present in all the terms, we can take it common. So we have 2 into minus root 2 plus minus 2 root 2 upon 2 root 3, which is equal to minus root 2 plus minus 2 root 2 upon root 3. So one root is given by minus root 2 plus 2 root 2 upon root 3. Minus 1 root 2 and plus 2 root 2 being like terms can be added. 2 minus 1 is 1, so we get root 2 upon root 3. Note that whenever the answer contains a root in the denominator, we rationalize it. Means we multiply both numerator and denominator by a number which will make the denominator a rational number. Root 3 into root 3 is equal to 3. So root 3 is the rationalizing factor of root 3. So multiplying, we get x equal to root 2 into root 3 upon root 3 into root 3, which is equal to square root of 6 upon 3. The other root is x equal to minus root 2 minus 2 root 2 upon root 3. Minus 1 minus 2 is minus 3. So we have minus 3 root 2 upon root 3. Rationalizing the denominator, minus 3 root 2 into root 3 upon root 3 into root 3, which is equal to minus 3 root 6 upon 3, which is equal to minus root 6. So the roots of this equation are root 6 upon 3 and minus root 6. I hope all the steps are clear. Now let us solve few equations which are not in standard form. As discussed in the earlier sessions, whenever there is x in the denominator, we remove it. Do you remember how? Yes, by multiplying the equation throughout by the denominator or the LCM of denominators if there are many. So multiplying each term of the equation by x, we get x square minus 1 is equal to 3x. To bring it to the standard form, we will move 3x to the left hand side. So x square minus 3x minus 1 equal to 0 is the standard form. So a is equal to 1, b is equal to minus 3 and c is equal to minus 1. The value of discriminant will be minus 3 square minus 4 into 1 into minus 1, which is equal to 9 plus 4 equal to 13, greater than 0. So the real roots are given by x equal to 3 plus minus under root 13 upon 2 into 1. That is 3 plus square root 13 upon 2 and 3 minus square root 13 upon 2. As these are rational and irrational and cannot be added, this is the final value of the roots. Now this equation 1 upon x plus 4 minus 1 upon x minus 7 equal to 11 upon 30, where x not equal to minus 4, 7. I discussed it in the earlier sessions also, but just in case someone has a confusion, these values of x are given to clarify that denominator is not 0 for any value of x. This can be 0 only if x equal to minus 4, but we have x not equal to minus 4. And similarly, this cannot be 0 as x is not equal to 7. Now let us convert this equation into standard form. We have to remove x from the denominator. It is a sum of two terms, so we cannot solve it like previous question. We will take the LCM on the left hand side. LCM of these denominators will be the product as they are different from each other. So we get 1 into x minus 7 minus 1 into x plus 4 upon x plus 4 into x minus 7 equal to 11 over 30. Now open the brackets and the negative sign will multiply with each term in the second case. So we have x minus 7 minus x minus 4 upon x square plus 4x minus 7x minus 28 is equal to 11 over 30. X cancels. Minus 7 minus 4 is minus 11. Denominator is x square minus 3x minus 28. Cross multiplying minus 330 is equal to 11 into this. Now as 11 is multiplied, I can bring it to the other side and we have minus 30 equal to x square minus 3x minus 28 or x square minus 3x minus 28 plus 30 equal to 0. So the standard form is x square minus 3x plus 2 equal to 0. Comparing, we get a, b and c, and so the discriminant is minus 3 whole square minus 4 into 1 into 2, that is 9 minus 8 equal to 1. So the real roots are given by x equal to minus b plus minus under root capital D upon 2a, or x equal to 3 plus minus under root 1 upon 2. Square root of 1 is 1. So the two roots are 3 plus 1 upon 2 and 3 minus 1 upon 2. That is x equal to 2 and x equal to 1. Now can you try out a similar problem yourself? Pause your screen and solve, and then we'll discuss the answer. I'm sure you were able to work out the answer. I have tried to touch all details, but still if you have any query or question, then please feel free to write in the comment section. If you want to know more about types of roots of a quadratic equation, then you can click on this link for the next session. And do support me with likes and subscribes. Take care and goodbye.